Hi, Sam here from Roberts Geospatial. Today I want to take a deep dive into the 3D Maps feature in ProRaster Scientific version 2.4. So there's a new YouTube video in addition to this one which will be coming up. And here's the ProRaster Scientific web page. Hit this button to go to the Microsoft Store. You can download and install ProRaster Scientific for free, and you get a 7-day free trial. And after that, you can choose to purchase or not as you see fit. But for 7 days, download it, install it, and have some fun. So let's take a look at this new feature. So here's ProRaster Scientific. The easiest way to get into it is to go new 3D algorithm and then choose the raster that you want to render in 3D. So I'll go to the Glow 30 raster for Australia. So this is a 30-metre resolution terrain data for Australia. So it'll open up the preview map in 2D and it will also open a new 3D window. So here's our window. We can navigate around this 3D surface and it will create a new algorithm for you. So let's just take a quick look at the algorithm. You can see that there's a new 3D surface layer. So if you go into Add Layer, in addition to these LUT color, RGB color image, you have a new layer type called 3D surface. So the 3D surface is the geometry upon which your other layers will be draped. So you can't have an algorithm that just contains a 3D surface. It won't render anything. You need to put another layer on top of that 3D surface. And by default, with this terrain raster, it's created a lookup table color layer and it's doing some color mapping. And so that color is what we're seeing draped on the 3D surface, which of course is the same raster. But it doesn't have to be the same raster. So your 3D surface can be one raster and then you can drape any layers that you want on it. So in your algorithm, you'll have your 3D surface at the bottom, and then all of the layers that you've got on top of that algorithm, on top of that surface, will be rendered into an image which is draped onto that 3D surface. And that continues if you have multiple 3D surfaces, so you can add in another 3D surface. And then in your stack of layers, the layers that are above that surface will be rendered on that surface. So when you have multiple surfaces, the layers that are between the top of from the surface up to the next surface, they will be rendered on that surface at the bottom, and then so on and it goes. So in order to organize that and keep that a little bit more organized, it automatically turns on grouping in the algorithm, and each time you add a 3D surface, it will create a new group for that surface. So you can have, so now I've got two groups. I'll have two surfaces being rendered. Of course, I haven't connected any data, but and you can keep them separate and manage them like that. So let's have a look at the 3D surface. So the layer properties. Firstly, it has a name. So it is a good idea, good practice to always name your surface. Give it an actual name because it'll show up in the property pages for the 3D surface, for the 3D map, and always a good idea to have a name that you recognize. Then for color properties, you have this opacity, so you can change the opacity of a surface. And you have your interpolation settings. It says color interpolations, but it's really sort of data interpolation. So you can use, nearest neighbor or bicubic, bilinear, and so forth. These are the settings that are used to interpolate your surface values. And then you have the surface component and you have a mask component. So unlike an imagery layer, there's only two components. The surface component is where you connect your data, so you have to choose a raster source. So choose one of those or browse to one of the rasters that you've accessed recently, or hit the browse button and go and browse to a raster and connect that to your surface. That's going to become the geometry. Choose your field, choose your band. If you have multiple time points, then you can choose your time range. You can also set the coordinate system. If it doesn't have a coordinate system and you know what it is, you can override it. And you can also use data conditioning. So the data conditioning filter is applied to your surface before it gets rendered. So you can use it to modify your surface. And if we go into our filters, you can see that down here there's this option to transform y equals ax plus b. So that gives you a way to transform your 3D surface via data conditioning filter before it gets rendered. And then again, we have our interpolation setting, that's an override. And then we have our mask component, again connected to some raster source. So this allows you to clip your 3D surface to the valid cells of some other raster. So that's just a clipping mechanism, and you can use that. So that's our 3D surface. Pretty simple. Just basically choose the raster that you're going to use as your surface, and then all of your layers that you put above that surface, they just get rendered perfectly normally in your 2D map. So you're going to see what it looks like in 2D, and then it will be reflected in the 3D map. Now, how do we open a 3D map? Well, go up to the algorithm and go New Map Window. So bring up the context menu and select New Map Window, and you can open multiple map windows. If you just have a 2D map open, you can right click on it, and there'll be an option down here saying Push to 3D Map. You'll only see that if you've got a surface in your algorithm. When you click on that, that will also open a 3D map if there's no map already open. If you already have a map open, then it does something different. So let's look at what that is. So I have my map down here. If I, say, zoom in on Tasmania, and now I go push to 3D map, you see that the 3D map updates to match the zoom level of the 2D map. So I've now zoomed in on Tasmania. So using this mechanism, you can display rasters of any size, at any scale. So, and as you zoom in on the raster, it will progressively bring in more and more high-resolution detail to display in the 3D map. But even at very wide levels of zoom, it's going to be going up the data pyramid in the raster. So it's going to be choosing the best data to display at every level of zoom, just like the 2D map. So, so we can zoom and pan around here and just continue to push out to our 3D map, and it will change the zoom and pan. And if you navigate down into your map and you're flying along, when you zoom and pan in your 2D map, it will update seamlessly so that you don't lose your view position. So let's come back out here, go out to a full level of zoom. I'll reset the view, and just so that we can see what happens. So if I come into the properties of my algorithm, and let's change the color scale to this, you can see that that's immediately reflected in the 3D map. So it's just like the 2D map, that when you change properties in the algorithm, the 3D map will update. However, it is a little bit slower than the 2D map, and it's not multi-threaded. So, so my advice to you is to build your algorithm in 2D without the 3D map open, and then open your 3D map to display, rather than editing the algorithm whilst you have 3D open. So let's add a layer let's put in a web map overlay. So now we've got a little bit of web map information, and that's immediately reflected in here. So you can see now I have two layers, and they are both being draped onto my 3D surface, which is my AusDM bottom layer. So that's how that works. So a little note on rendering performance. So ProRaster has always used your graphics card to render 2D maps. It's now going to be using your graphics card to render 3D maps. But 2D is a much simpler proposition, and if you have both a graphics card and integrated graphics on your CPU, then it's most likely using the integrated graphics by default. Now that you're doing 3D, you're going to want to use your external graphics card if you have one. So go to your graphics settings for Windows. So it's in your settings dialog, system display graphics. You want to make sure that ProRaster Scientific is using your external graphics card if you have one. So go to the Microsoft Store apps, and then down in the list you'll find ProRaster Scientific. Click on it and select options, and you can see that you'll have power saving, that's your integrated graphics, and high performance, which is your external graphics card if you have it. You should select this high performance option, hit save, and then reboot your computer. To make that setting stick, you may need to reboot your computer. So that's something you might need to do. Now, let's take a look at the navigation modes. So if you right click on your 3D map, you'll get this pop-up menu, and you can see that there are 4 navigation modes: spin mode, drag mode, explore mode, and fly mode. There's a reset view option, and that just resets the view transform back to default. So there we are, back at default. And then down the bottom you've got your 3D map settings, and that brings up your settings dialog. So let's reset the view and let's go into spin mode. So this is a very simple viewing mode. Hit the mouse left button and it will spin the thing around. So as you move the mouse away from the center of the view, both the speed of the spin and the direction of the spin and the axis of the spin will change. So that's just a simple spin. And then to zoom in, use your mouse wheel. You can zoom in like this and zoom out again. You can either roll the wheel, or you can press the wheel down, hold it down, and this becomes your middle mouse button. And now you've got a ballistic zoom, so you can zoom in and out. As you move the cursor up and down, that will zoom in and out. And that's common to all the modes except fly mode. So that's your spin mode. Let's reset the view and go to drag mode. Drag mode is very much like Google Maps. So left click and drag, and that will pan you around on the surface. So let's zoom in by rolling the mouse. Roll the mouse button, then grab and pan around. That's just like Google Maps. You can also hit the control key and that will rotate you. Again, just like Google Maps, go left and right and it will rotate, and up and down. Although in this system you have more control over your rotation. You can rotate, Google Maps a bit restricted. And then finally hit the shift key and it's panning up and down. So left and right and up and down with the shift key held, left and right, forward and back with just the left mouse button. So that's the explore mode. Let's reset the view and go in, sorry, that was drag mode. Now let's go to explore mode. So explore mode gives you a little bit more precise control over your eye position and your look at position. So in 3D, to establish your view transform, your eye is going to be looking at some point in space. So you can control where that point in space is, you can control the distance between the eye and that point in space, and you can control where the eye is in space. So in explore mode, firstly hit the mouse button, left mouse button, and you've got rotate. Now, what's happening here is the eye is rotating about the look at position. And depending on where you move, it's just like spin mode, depending on where you move the mouse, it will rotate left or right, up and down. Use the mouse wheel again to zoom in. Now what that is doing is actually moving your eye towards the look at position. So you're coming towards the look at position. Now you can move the look at position. So if I hit the control key and the left mouse button, you can see that there's a little crosshair now displayed on the screen. That's the look at position. So if I zoom out, the look at is now further away. Now with the control key, I can move left and right and forward and back, and I can move around the surface that I want to visualize. I can also hit the shift key. Now I'm moving left and right and up and down. So that gives me complete control over where I put that look at position. So for example, I can put it over here next to the Flinders Ranges, and then when I spin around, I'm spinning around the Flinders Ranges, and that's remaining in the centre of my view, and I can zoom in and spin around it. So that's the explore view. Let's reset the view. The last one is fly mode. So fly mode is a bit like a flight simulator. You don't have any roll, so your head is always vertical. So probably the thing to do is to firstly just zoom in to the area where you're interested in get control in starting, and then go to fly mode, and now hit the left mouse button to rotate your head around in the normal fashion, and in this case you're rotating on the spot. We're not rotating about some point in the view on the surface. We're rotating our eye on the spot. Then hit the control key and the left mouse button, and now you'll start moving forward. And you can see up here there's a little speed indicator. Use the roll button to increase or decrease your speed. So now we're going slowly, and we can roll our button, and now we're going fast. So just point the mouse in the direction that you want to go, and you will fly in that direction. Hit the shift key and you'll go backwards. So now I can zoom up backwards and move away from my surface. Control key to go forwards, fly down and zoom around. So that's the fly mode. Okay, so let's look at some of the properties of the 3D view. So I'm going to use my map to zoom in on Uluru. So I'll just find that over here. There it is. Zoom in a bit more. And I'll go to my colour component, just make that a little bit higher resolution. So I'm going to push that to my 3D map. Here's my 3D map, and we're looking at Uluru in the centre of Australia. So if I right click, I can bring up the 3D map settings. So here's all the settings for your 3D map. So firstly down here we have 3 buttons for saving, loading and resetting defaults. So you can change these settings and then say save default. That will save it to disk, and every time you open a 3D map thereafter, it will use those settings. If you've modified the settings, you want to go back to your saved settings, you hit Load Default. If you want to go back to the factory settings, hit Factory Reset, and then hit Save Default to make sure that those factory settings are saved as the default. So there's some options there. Now, let's look at these settings. Firstly, up in the resolution box, we have our surface mesh and our image pixel sizes. So the mesh is the geometry, and at the moment I have it set to 512 cells by 512 cells. My image pixel size, that's the image that's being draped on the geometry, and currently that's set to 1024 by 1024. So you can bump these settings up if you wish. And how far you'll be able to go with that and still get a smooth rendering depends on the capabilities of your graphics card. You can also change the lighting. So I'm not going to give you a big primer on lighting, but you've got basically ambient lighting, diffuse lighting and specular lighting. So all of these things range between 0 and 255. So for example, if I set my ambient lighting down to 0 and I set my diffuse lighting to 255 and set my specular lighting to 0, hit OK. Now I've just got a shaded surface where all the light is coming from one direction and lighting that surface. With a bit of ambient light, there's more light all over the place. And now we've got probably too much diffuse light. Anyway, let's go factory reset, take it back to standard. On your lighting, you've also got the option to do both either a directional light or a positional light. So by default, it's a directional light. That means the sun is shining from a direction that is relative to the eye. So as you rotate around, the sun rotates with you. And so the shading on the surface changes. You can also put a light into the scene. Now that's a positional light. So with a directional light, you specify these three components of the directional vector, x, y, z. With a positional light, you specify the position in view coordinates. Now the view goes from -100 to +100 in x, y, and z. So if I put a light at 100, 100, 100, and I turn off my ambient lighting, and I'll turn off my specular lighting, and I'll make that just diffuse. Now I've got a light in the scene. So I put it out here in positive X, Y, and Z, and it stays out there. So as I rotate it, the shadow remains the same. So the light's always coming from the same direction. And that might be useful. So usually when, for example, you colour modulate your surface, you usually don't turn on your intensity. So I can turn that on, for example, now it comes on the 3D map. But the intensity in 3D is usually provided by the shading, the lighting system. So usually turn it off. But if you do want to add in some additional shading from the 2D system, then you can do that, and it's a good idea to use a positional light so that it's coming from the same direction and it doesn't change. Okay, let's go back to normal. So that's our lighting, and then we also have this embellishment. So you can see up here, show on-screen report. Here's our little report that is on screen all the time. So we have a width and a height, so it's telling us the width of the scene, in this case in meters, so we're almost 6 kilometers wide. The height is the vertical height difference from bottom to top, so we're 343 meters from bottom to top. It's telling us our vertical scaling exaggeration. So at the moment we've got a 2-fold exaggeration on, and it also tells us the units in the horizontal direction and the units in the vertical direction if it knows what they are. So our horizontal units are derived from our coordinate system. The vertical units will be derived from the raster that's being used for the 3D surface. Usually rasters do not tell you what their units are. Unfortunate, but true. So that's why it says here vertical unit meters, question mark. The question mark indicates that it doesn't actually know, but it's making an assumption that they're meters. Now, it's important that you know that because it will apply a scaling factor to equalise your horizontal and your vertical units. So if your horizontal units are in feet and your vertical units are in metres, then there's going to be a scaling factor in there of around 3 to equalise those units so that when you look at the view, it's 1:1. So that's the information there. You also get a heading. So you can see as I spin around, that heading will change. And there's a little compass here that's showing you the north direction with the red arrow, and the little dark arrow is showing you the actual view direction, the way that you're actually looking. So that's your on-screen report. You also have a 3D axis. So you can turn on this 3D axis, you get an XYZ axis. It shows you, it annotates that axis with your units, with your coordinates in X, Y, and Z, and you can turn that on if you wish, if you need to orientate yourself. Okay, raster. And I'll just show you one more thing, and that is interpolation. So if you go to your 3D surface, here or here, doesn't matter where, and you change the interpolation option to nearest neighbour, then it actually changes the way that it renders the whole thing. So you can now see that Uluru is made up of a series of bricks. Now this reflects the actual resolution of the raster that we're rendering in this case. So it's a 30-metre raster, and Uluru is about 3 kilometres long, so you get about 100 blocks, as you can see. And so that shows you exactly what the resolution of your raster is in 3D. So you won't normally use that mode, but if you want to swap into that mode so that you can get an idea of exactly what you're looking at in terms of your raster resolution, well, you can do that. Let's now look at the transparency settings. So I'll close this one out and I'll go back, I'll go to a different algorithm. So here we have two groups, my terrain group and my magnetics group. Let's push this into 3D. Just wait for that to catch up. There it is. So we have a terrain surface underneath, and I've got some maps, imagery displaying on that terrain surface. And then on top, I've got a magnetic surface. So this is measured magnetics, magnetic field of the Earth at a local level where there's lots of anomalies which reflect the magnetic properties of the geology. So we have a magnetic surface, and that's being coloured by itself. In the colour, I'm doing some clipping to these limits. So that's why the surface is clipped here at the blue. And we're only seeing these red and green areas, which are the positive anomalies that we might be interested in. So I'll just turn off the opacity for this surface. And that gets reflected over here. So here's our 3D surfaces. What are we in drag mode? So we have two surfaces, the terrain underneath and the magnetics on top. Now when we go to our 3D map settings, we can change these vertical transform options. So there are 4 options. If you've only got one surface, you'll only see the first 2 options. But when you have multiple surfaces, you get additional options. So firstly, auto uniform. So the scaling is automatic. The scaling is uniformly applied to all of the surfaces and you can't change it. So that's the first setting. Auto scaled. The scaling is automatic. It's applied uniformly to all surfaces, but you can change it. So now I can edit this scale. I can put in 5 and you can see that the scale just changed. So magnetics have got a bit different there. Okay, next setting is auto stacked. Again, no options. So everything is automatic. The scaling for each surface is going to be computed individually for that surface. And then the surfaces are going to be stacked in space on top of each other uniformly. And I think I need to do a little bit more work on this to improve it. But you can see that now I've got two surfaces separated in space. So this space, the coordinates of this space go from -100 to +100. And you can then move these surfaces up and down in that space. And you do that by then selecting the manual mode. So now we have a list of all the surfaces that we're rendering. So select the surface you want to change. You can change the scale and you can change the position. So this can be between -100 and +100. That moves it up and down in that space. So we've moved it up to the middle and we've given it a big scale. You can see the scale changed. It didn't move very much, and I think that's a bug. I'll have to fix that in the next little update. You can go to your other surface, magnetics, change that scale, bring that down, and you can see that came down and the scale has moved up. So you modify those positions and you can get the view just the way you want it. So let's look at opacity. I've made some notes in the ProRaster user guide about opacity and the various ways that opacity will be triggered in a 3D algorithm. So you should go and read that. But let's just look at it in practice. So we have our surfaces here, the magnetics. I'm going to go to the magnetic layer and I'll bring down that opacity a fair bit. You can see it's immediately reflected in the 2D map, and then a moment later the 3D map also updates. And you can change this opacity and it will be reflected in the 3D map pretty much straight away. So now we're able to look through our top surface and still see our bottom surface underneath it. Now, rendering transparent surfaces in 3D is a difficult problem. So there are some options for rendering these surfaces. And that's here in the transparency option. So there are 4 options: standard, see one way, backsort 2 and backsort 4. So if I put it on see one way, hit OK, what happens is we can now see through the surface, but we can't see the surface through itself. So it might be hard to judge. You need to play with this yourself. But we can see the terrain through the magnetics, but we can't see the magnetics through the magnetics. So that's one way of handling transparency. It's not a realistic way, but it's one way, and it might be an effective way if you have one transparent surface that you want to see through to another opaque surface. So the way that transparent 3D graphics needs to be rendered is it needs to be back sorted. It needs to render from the back to the front. That's very difficult. But there are two options here which are sort of pseudo back sort options. One will generate two sorted lists of fragments. The other will generate four sorted lists of fragments. So the 4 uses a little bit more memory, but there's no performance penalty for using these options. So I'm going to use backsort 4. Now you can see through, I think we just need to bring our transparency down a bit. Now we can see the transparent surface through itself, and it makes sense. We're looking, it's rendered appropriately so that the things that are closer to your eye contribute more of the colour than the things that are in the background. So these are what are called high depth complexity transparent surfaces. Difficult to render, not going to be rendered perfectly, but we do a pretty good job and with good performance. So that's transparency. So that's the 3D map in ProRaster Scientific. It's designed to render any raster in 3D. Doesn't matter how large the raster is. You can look at it at any scale. It's going to make a nice picture for you. It's not a continuous level of detail system like something like Google Maps, but for the purposes of being able to understand your data and to make discoveries in your data, then I think that it suits that that goal. And I hope you enjoy it.